Welcome to the TEEP Podcast, brought to you by the State Energy Conservation Office of Texas and Energy here in Houston, Texas. I'm your host, Gary Gildert. I'm joined by Communications Director Benita Roy and PhD candidate Shahriar Hussain. Communications Manager Brenda Cruz and Media Engineer Christian Garcia are in the background making things happen. We bring you the latest in industrial energy efficiency in 15 minutes or so. First up is Benita telling us about upcoming events.
Please check the event calendar on the Energy website for updates on upcoming events as they become available. First up, we have the event Mechanical Vapor Recompression in Chemical Processes, Real-World Success Studies. This is on July 21st, Tuesday from 10 a.m. This webinar will provide an overview of modern MVR solutions and their application in chemical process environments. Attendees will gain insights into how MVR technology can optimize thermal processes, enhance energy recovery, lower operating costs, and improve operational reliability. Real-world examples will illustrate practical approaches to integrating MVR systems into demanding production environments. Next, we have the elimination round of the Chevron Innovation Competition on Friday, July 24th from 2 to 5 p.m. The University of Houston will host the 5th Annual Chevron Innovation Commercialization Competition, a dynamic event that empowers students to transform cutting-edge energy research into real-world solutions. This event is sponsored by Chevron and coordinated by Energy, underscoring our commitment to innovation, entrepreneurship, and energy transition leadership. The 2026 STEAM System Masterclass workshop is on August 20th and 21st at the University of Houston Technology Bridge. After hosting successful masterclasses the last 2 years, TEEP is organizing the STEAM System Masterclass workshop in 2026 too. The workshop is taught by James R. Risco, MBA, CEM, PEM, presenter, consultant, author, and inventor. Jim is the retired president of TLV Corporation in Charlotte, North Carolina, formerly responsible for US and Canadian operations. You can register on the Energy events calendar. Use code EARLYSTEAM before August 1st for an early registration discount. Check out the SPEAR website for webinars and information for small and medium industries as well as commercial properties. All episodes of the TEEP podcast are now on YouTube, also available on Spotify and Apple Podcasts. Over to Gary to talk about the 2026 Southwest Process Technology Conference.
Thanks, Benita. I'm looking forward to this event because SPTC features 2 energy efficiency sessions. The deadline for abstracts was June the 19th, but if anyone listening to this podcast has a good idea for an energy efficiency presentation, please submit it through the portal and send me an email. Registration is open with early registration discounts and discounts for groups of 5 or more. Attention industry folks, we encourage you to become SPTC sponsors to gain visibility for your organization and build relationships with prospective clients. Sponsoring organizations will have access to reduced registration rates for their members. See the June newsletter for more details of this spectacular event. Last month was quiet with respect to TEEP, but there were 2 events that I would like to mention. First was Home Energy Rebates. These are 2 new programs that provide rebates to eligible households, up to $8,000 in the Homes program, and $14,000 for the HERE program. These are to make energy efficiency improvements and reduce energy costs. SECO hosted this event on July the 13th. Now, it was originally planned in person, but it was moved online due to weather. Now, they are seeking community input to ensure that these programs best meet the needs of the community. Please go to the SECO website for more information. The second thing I'd like to mention was a visit I made to Lummus Technologies in Pasadena, Texas. They have some amazing pilot plant facilities there, developing some new processes. I was reacquainted with my old friend, Dr. Gary Podraberic, who I first worked together with, over 25 years ago. Look, I think I can't say too much. I was under an NDA at the time, saw this amazing stuff. And I think we're going to have to get him on the podcast and some future forums to talk about some of the amazing work that they're doing. We are joined this week again with Shahriar, who's going to talk about oxidative dehydrogenation of propane. So remind us, why is this technology important?
Sure, Gary. So as we discussed in last month's newsletter, propane dehydrogenation is an important industrial process because it provides an on-purpose route to propylene. Propylene, as you know, is a major feedstock for polypropylene and many other chemicals. Historically, propylene was mainly produced as a co-product of steam cracking and refinery operations, but as cracker feeds have become lighter, propylene production from these routes has decreased.
So briefly tell us a bit about the chemistry and the thermodynamics of both PDH and ODH.
Yeah, well, the basic PDH reaction converts propane into propylene and hydrogen. This is a strongly endothermic reaction and it requires continuous supply of high temperature heat. This is also equilibrium limited, so propane conversion is favored by high temperature and low pressures. So maintaining these conditions helps shift the reaction forward toward propylene and hydrogen in the reactor.
And what about ODH?
So for ODH, or oxidative dehydrogenation, the change in chemistry is by introduction of oxygen. This removes hydrogen as water, and it makes the overall reaction exothermic, thus releasing heat rather than consuming it. It also removes the equilibrium limitations of direct rehydrogenation. Oxygen consumes the removed hydrogen, which drives the overall reaction forward. These are the main theoretical advantages for ODH, and they make it possible for lower reactor temperatures, higher operating pressure, and lower external heat demand.
Okay, this sounds pretty good. So which energy metrics did you use to evaluate and compare these processes?
Yeah, so we use the 6 main energy metrics from last month's newsletter. We considered net feed preheating, reactor energy input, and compressor duty. We also looked at the catalyst regeneration duty, the separation energy, and the net material energy credit. Together, these metrics describe the overall energy input required for the processes.
So this exercise was looking at, well, you started with an ideal propane dehydro operation and compared this to the industrial. So tell us how those compared.
Yeah, so the ideal PDH case assumes a perfectly selective reaction. It assumes that no coke is formed and there is no cracking.
It all sounds pretty ideal.
It is. It also assumes that there is no catalyst deactivation, so dream come true.
And what's reality now?
So the industrial PDH is, of course, much more complicated. Real catalysts can form coke and side reactions and can also consume propane. These would produce propylene selectivity overall. Practical process produces more gas, which increases compressor duty, and lower selectivity increases the propane feed requirement and slightly increases the downstream separation burden.
So you also compared this ideal propane dehydro operation with an idealized or ideal oxidative dehydrogenation process.
Mm-hmm.
What did you see there?
So the ideal ODH has several clear advantages. The reaction releases heat instead of requiring it, first of all. It's not equilibrium limited anymore, so complete conversion is theoretically possible. It can also operate at higher pressures, which reduces downstream compression. And with complete conversion, the ideal case has no unreacted propane to recycle, and this can eliminate the majority of the separation energy demands.
Can certainly see the appeal of this. That's got to be the way to go, but it's not. So what's wrong with this picture?
Yeah, so the main problem is incomplete selectivity due to overoxidation. Propylene is often more reactive than propane, and after it forms, it can react further with oxygen to produce carbon monoxide and carbon dioxide, including all the other byproducts.
So in other words, as you're making propylene, you're burning it.
Yes, exactly. That's what's happening. This is the main challenge, essentially, to stop propylene from over-oxidizing. And so many ODA systems must operate at low propane conversion to preserve the selectivity. This means unreacted propane still requires separation and recycle downstream.
So these three advantages that you outlined for the ideal case of very low separation energy required and more energy efficient, these all seem to be disappearing as we look at the real systems. So what have you learned about the research into these catalysts for ODH?
Yes, so the research is mainly to address the challenge for selectivity right now. We need to find good catalysts that stop this overoxidation. but although I don't think it's possible to completely remove it, the catalyst must perform multiple things at the same time. It must activate propane while allowing propylene to desorb quickly. For catalyst to have good turnover, it must also control the reactivity and concentration of oxygen at the active site properly. One approach is to separate oxygen activation from hydrocarbon activation, or use lattice oxygen in a redox cycle. Chemical looping concepts can expose propane to controlled solid oxygen rather than direct gas phase oxygen. There are also membrane reactors that may regulate oxygen delivery.
And this is probably going into way too much detail than we can handle on the podcast right now. But you're writing up some really interesting material on this. That some of it's going to be in the article this month. And I need to talk you into writing up a little bit more for next month as well, if you're up for that.
Sure. I'm happy to help.
Okay, so this has been a great discussion on, I'd like to call it an up-and-coming process, but it's been around for a little while, but I think there's some really exciting new catalysis work being done on the oxidative dehydrogenation of propane. Thank you for listening to the TEEP podcast, brought to you by SECO and UH Energy. We were joined today by Communications Director Benita Roy and PhD candidate Shahriar Hussain. And many thanks to Communications Manager Brenda Cruz and Media Engineer Christian Garcia for their wonderful work behind the scenes. I'm your host, Gary Gildert, and we bring you the latest in industrial energy efficiency in 15 minutes or so. We'll be back again in a week or so for another interview.